In the first session of this training, we looked at the various aspects that should be considered when conducting an assessment of alternatives. These aspects include defining the goal of your efforts, identifying the products and processes involved in the assessment, and understanding the function and purpose of the chemical you are interested in removing. In this session, we'll look more closely at the next step in the assessment, which is both critical and challenging, identifying potential alternatives to the chemical of concern in your application. While this may seem like an obvious next step, it is not an easy step. Fortunately, the impact of your previous scoping efforts will help you in narrowing your search for possible options. There is no one-stop shop for finding an alternative to a hazardous chemical of concern. As practitioners, you must take advantage of a variety of resources and employ various techniques in your efforts to seek and find viable, safer alternatives for your specific application. After completing this session, you will have a better understanding that alternatives can come in many forms, including chemical substitutions, alternative materials and technologies, and changes in the product or process that may eliminate the need altogether of the function you are seeking to replace. You will also gain an understanding of how the function of the substance you are seeking to replace informs choices about possible alternatives. You will know where to seek information about possible alternatives. And lastly, you will know how to screen out problematic substitutes and focus on the most feasible potential alternatives. Finding a one-for-one chemical change that is the perfect drop-in replacement is often the first place people's imaginations go when considering the options available to them. And sometimes that exists, but usually if a drop-in does exist, companies have already turned to this alternative unless the performance or economics are not ideal. Revisiting these options periodically may uncover new circumstances that make it more favorable than it may have been initially. So for this reason, it's always advisable to track and document the ideas that you generate as you consider your options so that you can revisit them in future AOA efforts. Alternatively, it could be that a mixture of safer chemicals could allow you to match the functional requirements of your chemical of concern affordably. If that doesn't work, perhaps entirely redesigning a product is the way to go. Think about what the function is that you're trying to replace and ask yourself if that function is necessary. And if so, are there other ways that you can achieve that by redesigning your product altogether? Another option to be considering when you're looking for ways to eliminate the use of a chemical of concern is, are there opportunities to redesign or change your process so that you don't need to use that specific chemical of concern? Are you using the chemical in response to something that was done upstream from the point at which it's being used? And if making a change upstream can allow you to eliminate your use of chemicals, this might be a really great option for you. Really asking yourself what is the function of your chemical is so important in the process of identifying what your alternatives are. And it may simply be that you don't need that function. Are you using a chemical in order to allow a certain bell or whistle to be experienced on your product that is a nice thing to have, but is not essential to the product itself? In that case, maybe you really don't need to do that. And in collaboration with your sales force, you can find a way to eliminate the need of that chemical and the need of that function. Finally, just looking at your overall system and thinking about what it is that you're doing and providing to your customers. And are there ways to get there that are more systematic? Can our operation be functioning in a way that allows us to really focus on reducing our use of chemicals of concern? These are all actions that should be considered when you're doing an assessment of alternatives and when you're looking for those ways of reducing or eliminating your use of a toxic chemical. We're going to be focusing on substitution primarily in this training. So that's This is just a reminder to you all about what you should be considering. In all of these examples, the identification of a viable alternative to your current use of a chemical of concern typically leads to many more questions that need to be answered before your company can actually implement the change. So remember, a potential alternative can be a chemical substitution. It may be a change in the materials that you use. It could be a product redesign or a change in your process altogether. All of these things may help you to achieve your necessary function that you're currently getting from the chemical of concern. So the best practice tip that we want to make sure that you walk away with is to always ask yourself if the function provided by the chemical you're looking to replace is actually necessary. We assume that chemicals of concern are used for a purpose. Understanding what that purpose is allows you to consider a variety of options that can achieve the function without use of a toxic chemical. So a functional alternative is one that, when implemented, achieves the function provided by the chemical of concern in your specific application. An example of a chemical or material alternative would be replacing lead in wheel weights with either a different metal or blend of metals, or with a non-metallic option. Process change alternatives can be associated with the action required to achieve your desired function, such as by sandwiching non-flammable barrier materials between the textile and foam components of furniture to retard flame without the use of flame retardant chemicals. Process changes might also be about examining the overall process conditions needed in your current process to help you identify opportunities. So one example would be accepting longer drying times that might be associated with switching from a solvent-based pigment carrier to an aqueous-based carrier in your printing operation. Another chemical substitution example would be replacing amino carboxylate chelating agents with readily biodegradable chemicals. And finally, reformulating your product can allow you to eliminate the use of toxics, as with the elimination of phosphates in detergents. It is true that drop-in replacements can often be found that work as well as the chemicals of concern. However, it's also true that there are many examples of drop-in substitutes that are as or more hazardous than the chemicals they are replacing. Examples of regrettable substitutions include replacing bisphenol A with bisphenol S or bisphenol F in epoxy resins, using perchloroethylene as an alternative to trichloroethylene for vapor degreasing, replacing methylene chloride in solvent-based spray adhesives with 1-bromopropane. In each of these examples, the substitute works, but it introduces similar or different hazards. Having as clear a picture of the environmental, human health, and/or safety implications associated with a considered substitute is essential to allow you to make sound decisions that can be reasonably relied upon to not put you in the position of having to go through the process all over again. Remember, chemicals that are in the same group or class as your chemical of concern may exhibit similar inherent hazard concerns. Yet often, significant data gaps on the health hazards for these potential substitutes exist. So, as a best practice, consider the importance of decision rules to address hazard data gaps. Regrettable substitutes often happen when we move to a chemical with little or no hazard data or information. Look for evidence that the substitutes you are considering are in a similar class, like the variations on bisphenols or the chlorinated solvents in the examples I mentioned. These classes can have similar toxicity profiles. If you find a possible alternative that seems to have a similar structure to the chemical of concern, that is a clue that more information on potential impacts is needed. I'll leave you with this note, one I mentioned in the previous session that bears repeating. No evidence on hazard is not the same thing as evidence of safety. It is important to know what represents a problematic alternative for your situation. Chemicals that are restricted by legislative or customer requirements would certainly fit this bill. Often these chemicals are restricted because of their hazardous properties. If a chemical is known to exhibit hazardous properties that are equal or greater to that of your chemical of concern, it also could be a problematic situation. If a potential alternative is on the candidate list of substances of very high concern for authorization, it is clearly not a good candidate for substitution. For international trade, using substances which remain in the product and are regulated in your export market is a concern, even if they are not restricted in your own market. Use international databases with classifications of substances in different regulatory areas to identify these. Be leery of chemicals in the same group or class as the chemical of concern. And of course, you must recognize the importance of decision rules on how to address the use of chemicals with numerous hazard data gaps. With new scientific data, you may learn that the substitute you've invested in presents issues that you have not prepared to manage. Broadly speaking, when looking for viable substitutes for your chemical of concern, you want to leverage your networks, search the internet, read publications. Here are some examples of possible outlets you can access for ideas. In-house expertise. This is always the first place you should turn when seeking ideas for possible opportunities to eliminate your use of a chemical of concern. Innovations that may not be in any database, such as process change innovations, which could result in better end product and cheaper process, have often already been thought of within your own company. It may be that ideas from past efforts could yield very favorable results now that technology and economics have shifted. Other resources, which we will explore more deeply in the following slides, include safer alternatives technical resources such as case studies detailing successful substitutions. Experience of other companies. You may have good working relationships with your peer companies and with your supply chain companies, and these could be a really great resource. Trade associations, many of which are focused on helping their industry sector stay relevant and competitive as the desire for a greener economy becomes more apparent globally. Government and university technological institutes and technical assistance centers. Scientific discoveries found in industry trade journals, scientific literature, or patent applications. And manufacturer and vendor expertise. There are numerous technical resources that you should be aware of and accessing at this stage of your AOA. We'll talk about each in a bit more detail in subsequent slides. These resources include examples of successful substitutions, data on performance and hazard associated with known potential alternatives, and tools to help in identifying possible solutions to the use of a toxic chemical in your application. The first tool or resource that I really want to talk about with you is the OECD Substitution Alternatives Assessment Toolbox. This website has been developed with the combined efforts of global actors in the alternatives assessment field, from regulators to practitioners. It's a very useful first stop for ideas on options that might be available to you. As you can see, it has a searchable database of examples of successful substitutions for a variety of sectors. You can focus your search on the technical functionality you are seeking, or by the industry sector or the chemical of concern. As this resource continues to build, the toolbox will become even more useful for practitioners like you. The Subsport project, initiated in 2010, was funded by a number of EU agencies, including the Life Plus program, EU's financial instrument supporting environmental and nature conservation projects throughout the EU, BAWA, the German Federal Institute for Occupational Safety and Health, and the Austrian Federal Ministry of Agriculture, Forestry, Environment, and Water Management, now the Federal Ministry for Sustainability and Tourism. The Subsport project team included experts from various member states, technical assistance providers, leading consultancies, and regulatory agencies and NGOs. The tool was officially taken over by BAWA in 2018, and new tools and case stories have since been incorporated into the Subsport Plus portal. As you can see, you'll find a number of resources to support your success in finding safer alternatives within this portal. The Safer Chemical Ingredients List, or SKIL, is a list of chemical ingredients arranged by functional use class that the US EPA Safer Choice Program has evaluated and determined to be safer than traditional chemical ingredients. This list is designed to help manufacturers find safer chemical alternatives that meet the criteria of the Safer Choice Program. It is searchable by functional classes that range from antimicrobials to enzymes to fragrances to polymers to solvents to surfactants. If a product is listed, it is given a qualitative score indicated by the symbols shown here. These symbols give the user a sense of the confidence level of the data provided and the product's hazard profile. ChemSec Marketplace gives you access to a growing suite of verified, safer alternatives to hazardous chemicals. The information can be searched based on industry sector, technical function, material article category, and/or legal requirements, standards, and third-party labels. Once you have found a promising alternative, you can contact suppliers directly through the Marketplace website. Pharos is a project of the Healthy Building Network, an NGO in the United States. Note here, however, that the data provided is not limited to chemicals used in the building industry. You can search Pharos for a limited number of functional uses as a starting place to help identify possible alternatives for your functional needs, such as surfactants, solvents, or preservatives. Specific chemicals in the database are also tagged regarding the functions they serve. We'll talk more about Pharos in session 3, as it's also a useful tool to help screen for hazard information. The Massachusetts Toxics Use Reduction Institute has a laboratory that has been assisting companies in identifying safer cleaners that perform well for their specific applications. The Cleaner Solutions database is derived from the results of the over 25 years the lab has performed this work. You can go to this database and tailor your search for a technically feasible alternative by looking for solutions for the soils and substrates specific to your process. If the lab hasn't looked at a similar aspect, they can do so for a nominal fee to help you find a solution that works for your application. There really are a lot of technical resources out there that you can be taking advantage of to try to identify the right solution for your search. The REACH registration dossier database is certainly one example that you may be familiar with. You can search the database for registered chemicals by product category and sector of use. This will give you a list of potential alternative substances. That can also be done with the classification and labeling inventory database. These are both really quite rich resources that you can take advantage of. There are tools out there that can also assist in determining if there are possible solutions to your use of toxic chemicals. So for instance, solvents are commonly used in many, many different processes. They're typically solvents that have been used for a very long time and are quite affordable and well understood. And often you hear the suggestion that there is no other solvent that can replace the solvent that's currently being used. And that may be true, but there may be a blend of solvents that can get you there. And the Hansen solubility parameters in practice software is a tool that you can take advantage of that will help you to identify the potential for a blend of safer solvents that can achieve the same results as the toxic solvent that you're currently using. There are also other portals that you can access to find information on chemicals and substitutes. One that I'll mention here is the Toxic Use Reduction Institute's Environmental Health and Safety Data Resources Guide. It's a portal that provides a lot of access to different resources for information. Ultimately, one of the places that you want to look whenever considering alternatives to a toxic chemical are the safety data sheets and the technical product bulletins associated with that chemical and that product. They're going to give you information on what are the aspects of the product that make it function the way that you need it to, that will guide you towards the possibility of some safer alternatives. Don't limit what you look for and what you access to help you identify the possibility of some safer alternatives to your use of a toxic chemical. Several departments in your organization can have insights on alternatives. Accessing the wisdom of the line workers, the product designers, the process engineers, the sales force, etc., is usually the first place to look for ideas on alternatives. Workers who carry out the tasks associated with those chemicals may have great ideas on efficiencies and alternatives that could lead to an effective substitution strategy. The designers of your product can consider ways to achieve the chemical's function in products in different ways. Engineers understand the function of the chemical and the criteria that must be met to make changes, and that really can help you to guide you when you're looking for alternatives. The sales and marketing staff know what clients are looking for and what they will accept. Also really important criteria to consider when you're searching for alternatives. Working with these stakeholders early when searching can lead to many more opportunities to explore further, to find the safest, most effective, and affordable approach to take. Don't forget to access the wisdom and experience of other companies when you are searching for your alternatives. You can do that by talking to your peers. Look for companies that can provide information about the safer alternatives they have implemented. Really, some companies are very willing to share the non-proprietary aspects of the work that they've done with you. Continuously strive to engage in your sector networks and talk to your peers in the sector. One way to hear from peer companies is to attend conferences and workshops on substitution. Remember too that some U.S. agencies and member state authorities have supported research on alternatives for industry sectors or have provided substitution assistance that is public. So you can look for that. And you really do want to be looking for case studies or reports that talk about successes in substitution for your industry sector. We've already looked at some of the resources shown here, like the OECD Substitution and Alternatives Assessment Toolbox and the SubSport Plus portal. Other avenues for information about what has been implemented in similar operations to yours can include the EU OSHA campaign, which allows you to search for substitution for a variety of case studies. The Danish Eco-Innovation case studies and reports, which includes a series of cases focused on eco-innovation projects funded by the Danish Ministry of Environment between 2008 and 2014. The Enterprise Europe Network, which draws from international partnerships from over 60 countries, has a database that includes information on sustainable practices in your sector. And there are a number of other sector resources, just a few of which are provided here. Trade associations are becoming more and more active in supporting their membership to find safer alternatives as a means of helping them remain relevant and competitive in this global marketplace. One example, the European Furniture Industry Confederation, was provided in the previous slide. Another example of a trade association-led effort is the apparel and footwear group, Affirm. Affirm's purpose is to provide a forum to advance the global management of restricted substances in apparel and footwear, communicate information about restricted substance lists, or RSLs, to their supply chain, discuss concerns, and exchange ideas for improving RSL management. This sector has been a leader in moving towards safer chemicals and materials through research, restriction, and empowerment of its members to encourage safer and more sustainable practices throughout its supply chain. Leverage the association networking opportunities that your trade associations provide. Use time at the industry trade association conferences to network with your colleagues and exchange information on safer alternatives. And encourage your conference organizers to hold sessions on the topic of substitution challenges and new alternatives that are relevant to your industry sector. Technological and academic institutes, clean production centers, and substitution assistance centers are rich sources of information on potential alternatives. To access the information and expertise they have, however, you first have to find them. To contact relevant institutes in your region can take time, particularly if you're looking for a specific expert who will be most useful to you. Start by conducting internet searches. Look for web pages and publications on topics related to your application and chemical of concern. Some institutes, like the Swedish Center for Chemical Substitution, which will support companies with information on hazardous chemicals and better alternatives as part of a circular economy, are just being launched, but are planning to have web-based resources on alternatives. Look also for technical assistance centers that focus on substitution support. Examples may include organizations like the Joint Research Center on Circular Economy and Industrial Leadership, which, among other things, provides information on best available techniques to reduce industrial emissions, including information on substitutions implemented. The UN Regional Activity Center for Sustainable Consumption and Production, which is a Mediterranean-based initiative that focuses on building capacity in a number of related topics. The Greco Initiative for Green Competitiveness, also a Mediterranean initiative, which focuses on showing the economic benefits that businesses can gain from an environmental approach. And the Green Center Canada, which conducts research and development to find green solutions to current industry needs. Scientific studies and innovations can often be discovered through a search for journals, literature, and patent applications. Industry trade journals often provide information about what is currently being used in the market and feature articles about alternatives to replace hazardous chemicals, especially when there are regulatory and market pressures for change. These articles may identify the companies that are using alternatives, and you can seek them out for further discussion. The scientific literature and patent reviews may provide information on alternatives that are in various stages of research and development. These may present currently unavailable innovations that you want to track and perhaps even support the development of to help you solve your specific issue. In many cases, chemical, material, and equipment suppliers can provide information on options to the use of chemicals of concern. Sometimes these suppliers may find it in their interest to keep things status quo, and they may downplay the effectiveness or the affordability of the alternatives. It's your job then to help them see that this attitude could result in them losing a client, which is of course a more powerful argument when you represent a large segment of their customer base. Other suppliers, however, may be actively marketing alternatives to hazardous chemicals in various applications or uses on their website. Look for those suppliers and see what you can find out. Internet searches can often reveal a number of different options that you might want to explore further. In the next slide, we'll hear from Elke van Asbroek and Hira Moorman of the Apparent team discussing their process for identifying alternatives for specific applications.
Good morning, my name is Elke van Asbroek.
And I'm Hira Moorman. We are directors of our Apparent team. Apparent team is a consultant company active in the implementation of chemical regulations. And for this, we help often companies in analysis of alternatives. As a part of this training, we were asked to share some of our experiences regarding the analysis of alternatives, and more specifically, how we collect different alternatives. Elke, can you tell us more about this?
Yes, of course. About the collection of the alternatives, it's important to understand that we work at the company to find alternatives, meaning that we're not looking for alternatives to a substance in general. We're looking for alternatives to a substance for a specific use. Within that company, obviously, you have experts that know a lot about the product, but mainly about their end product. And that knowledge is what we use to define the key functional requirements of, on the one side, the substance, and the other side, the end product. The substance, important to know what is the function, what are the key requirements such as vapor pressure, temperature, solubility, others, many others.
Many others.
Okay.
Both physical and chemical properties are often required there.
Yeah, so that's what we define for the substance. For the end product, this has to do with what the customers want. The specifications of the customers are obviously also key in that area. Examples there can be
how fast it has to work, how precise it has to be, for what kind of audience is it made? Is it something you need to use at home, or is it something you use in a professional context? These kind of requirements clients may have.
Yeah, so those are listed, are discussed in detail with the client. It seems like a simple process, but it takes quite a while to get to all the specifics. And this basically starts a search. When we're talking about the substance, on the one hand, to look for alternatives, we then go to the suppliers, the existing suppliers, but also potential future suppliers that can be of help in that area. See if they have anything already available on the market or in the pipeline to come on the market as a potential alternative for the substance. When we look at the key requirements of the end product, there the customers, as I mentioned, come immediately as a resource for information, because we have these specifications, but are they really so stringent? Can we tweak here and there a little bit that with another substance, for instance, and some changes in the process together, we can come to a good alternative. So then it's a combination of potentially different substance and a change in technology. You want to add something there, Hiram?
Often it's not a binary decision whether or not something is an alternative, but it's a question how good an alternative something is. So in that sense, you may not be able to fulfill all customer requirements, but maybe 90%. So for that measure, the alternative might be a 90% alternative.
Yeah, and indeed, that's important. It depends on the customers, on the market where it is provided. For instance, gelatin for gummy bears is not the same as gelatin in the biomedical world. You have different requirements. When we look at the end product, the requirements of the end product, we also look at what competition is doing. Obviously, due to competition law, we cannot discuss this directly, but quite a bit of information can be easily found on the internet.
Competition is interesting because it allows you to, as a third party to the company seeking the alternative, to challenge that company in their listing of alternatives. They claim we are the only ones. Yes, but we found the other one. So how do you distinguish yourselves from the competition? What is your key selling point? Why you have something specific in the market? That is very important to reveal, and sometimes from a different audience than the R&D man, which you would contact for the critical or the key functionalities.
Mm-hmm. Indeed. So as I said, the R&D person within the company is our first source. The second is the suppliers of the company for that one substance, the customers of the company, the competitors for the end product. And as I said, we Google quite a bit to find more information on what our client is doing, what their competitors are doing, what other products are in the market. Last but it's not even last, then we have our databases that we go through. We have the Whipple Green, Subsport, Marketplace. We also use My Chemical Monitoring quite a bit. They don't provide alternatives, but when we get a feeling of what an alternative could be, My Chemical Monitoring can be used to see whether there is any scrutiny about this product already somewhere on the globe. So it tells us what the intrinsic properties are and whether it's under scrutiny under whatever legislation.
On the note of databases with alternatives, we have noticed that some databases are structured based on the substance to be substituted, let's say the substance with hazardous properties, and other databases are more structured on the basis of the technology they provide. Our experience is that when you're looking for an alternative, the most easy entry is the substance you want to substitute. Reason being that is the entry in the database will already take into account the original substance and how it compares to the new substance. So it's, some thought process has already been done and some bridging has been done. While for totally different processes to substitute your work or your process, the distance is often larger and it's more difficult to make the bridge between what you are doing and what the alternative process is offering. So our preference is databases with a key entry on the substance to be substituted.
Exactly. And then one that we use a lot as well are conferences on green chemistry. It is quite broad. You have to go there totally open-minded with the idea we will not find anything today, but there are lots of people like that and there are open discussions. And as such, we've come across alternatives in the past for a use that was totally different than the use that we were looking at, but with similar key functional requirements. And hence we could then try to implement it for the other use. These are the kind of alternatives that typically take long because it's innovative, but also leading to substitution that is really going to much lower hazard or even no hazard. Yeah. And with other potential benefits to the environment like energy saving, etc. That one there, the example that we have there that has been discussed many times before is a case of batik textile, where trichloroethylene is used as a solvent to dissolve the resin from the batik textile. And we're looking now at the solution, which is not hazardous, saving energy as well. It's called switchable solvent. It's in the early stages, but investigations are ongoing, are positive, some additional changes need to be made, etc. But if this works, this is quite a neat process. And that are the kind of alternatives we're looking for when we go to these green chemistry conferences.
Yeah. In general, a good source of information is also your network, your professional network, which you can build, and conferences is certainly there one entry point for.
Yeah. So in summary, the sources that we dig into are first of all the R&D guys or the experts within the company. Secondly, the suppliers of the company for the current SVHC substance. Thirdly, the customers. On the fourth place, competitors. Then we have simple Google, our big friend Google. We have databases and we have conferences. Yeah. Basically the network. Yeah? That's the same. Voilà. Thank you for your attention.
If the number of possible safer alternatives that you have identified is large, it is a good practice to screen the list to a more manageable number for further comprehensive assessment and potential adoption. You may want to put your list of options into different buckets. a bucket for the short list of alternatives that you have a good feeling about, and another bucket for those alternatives you suspect may not currently represent technically or economically feasible options. You want to screen out those alternatives that will not meet your specific criteria, which can include company-specific criteria, key functional performance and/or customer requirements. This often includes the availability of the alternatives, legal restrictions, or the presence of a chemical on authoritative lists of hazardous chemicals of concern, internal goals or principles or decision rules that you have set out in your scoping process. It's important to screen out clearly inferior or unacceptable alternatives. Clarify what your key performance criteria are at this step. This doesn't mean you will use every performance metric associated with your process or product. Focus on the variables that are of the highest priority. Customer specs and processing requirements can help. As part of your scoping efforts, you should have already identified the hazard and exposure characteristics your company is trying to avoid. These become very useful screening criteria. As mentioned previously, some of the alternatives you may identify may still be in the R&D stage. While they may present exciting possibilities, the time frame associated with getting to production may not be feasible for your efforts. If these materials or technologies are particularly interesting, however, you can think about supporting the R&D to help get to production level quicker. It's important not to rule out alternatives on the basis of cost at this point in the assessment. While cost is, of course, an important consideration in your choice of an alternative to implement, there are ways to reduce costs through process changes and purchasing agreements that can make what currently seems to be outside your definition of economic feasibility actually doable. For this reason, questions of cost feasibility are best addressed during the full assessment. Use existing performance information from case studies or trade publications or conversations with internal experts or customers and other stakeholders to help you in screening out infeasible alternatives. One way to work with stakeholders is illustrated by the Green Chemistry and Commerce Council, or GC3. The GC3 examined phthalate plasticizer alternatives. They screened from 100 options down to 11 based on discussions they held with suppliers. They employed an interesting process to achieve this, using an expert panel as a criterion instead of a list of criteria. Basically, they let the panel elevate key parameters in the discussions as a way of prioritizing criteria. This is a good approach for a high-level screening of options when you're not driven to find alternatives because of a regulatory action. Work with others in your sector to identify which options are most widely used and why that is. It's another great way to identify criteria to screen out problematic alternatives. And always document your decision rules and reasons. It's important to be clear why specific alternatives were not considered for further evaluation. Be transparent about your process so that it can be replicated in the future if necessary. And always document any assumptions you've made when screening out potentially problematic alternatives. There are a lot of different variables that may affect your decision to consider an option further. Focusing at this stage on what might make an option technically infeasible is critical. Here are a number of possible considerations that your company may use. Think about what process your company uses to make business decisions. What criteria do you consider? Who needs to be part of the process at this point? This is an important opportunity to engage with key internal stakeholders as you look at your potential alternatives. One of the main drivers companies have for assessing their use of toxic chemicals is restrictions on their use. Face it, you certainly don't want to find yourself considering an alternative that may face similar restrictions either now or in the future. To quickly screen out substitutes that may present current or future restrictions, you can utilize a number of resources, including the REACH candidate list of chemicals of concern. The European Union is a global leader in identifying chemicals that should be restricted from commerce. Several pieces of EU legislation refer to a list of substances of concern for which specific legal requirements apply. Some examples are the candidate list of substances of very high concern and the list of restrictions under REACH. Another example is the substances listed under the Restriction on Hazardous Substances, or ROS directive, for electrical and electronic equipment. Check ECHA's Information of Chemicals page shown here, which summarizes for any given substance information on its classification and regulatory status under 40 pieces of EU chemicals legislation. It also includes information from the Public Activities Coordination Tool, or PACT, which provides an overview of the substance-specific activities that authorities are working on under REACH and the CLP regulation. This provides an early warning about potential future regulatory measures. There are a number of commercial databases that provide information on regulations and restrictions that impact your choices. We've already spoken about the OECD's Substitution and Alternatives Assessment Tool. Another rich resource is the FAROS Chemical and Material Library, which provides a screening list of a broad range of international authoritative restrictions and regulations, and notes which health and environmental endpoints are of concern. You'll hear more about this in session 3. There are many other commercial databases similar to the FAROS database that you can use. Non-governmental organizations like Sweden's ChemSec have begun itemizing chemicals of particular concern. These lists go beyond current regulatory restrictions and provide insight into possible future actions to remove chemicals from commerce. If your chemical is present on the ChemSec Substitute It Now or SIN list, you would be wise to avoid it. Many manufacturers are part of industry sectors that face specific restrictions on their use of chemicals. If your company supplies the defense, aerospace, automotive, pharmaceutical, food, or other sectors, you may well have to address unique specifications that limit your use of certain chemicals. Another example is the AFFIRM restricted substance list that we talked about earlier. You should carefully document which authoritative lists or restrictions formed the basis for excluding any potential alternatives you have considered. Finally, the goals, principles, and decision rules you adopted in the scoping efforts we described in session 1 provide important clues to what constitutes a problematic alternative. Your company may have determined that it doesn't want to consider any chemicals that are carcinogenic, mutagenic, or toxic to the reproductive system, or you may have a mandate to avoid use of persistent bioaccumulative toxics or very persistent, very bioaccumulative chemicals. You may want to avoid any chemical that potentially impacts the endocrine system of your workers or customers. You may have a desire to eliminate the use of any skin or respiratory sensitizers from your manufacturing operations. You may be more focused on your impacts on the environment and want to avoid atmospheric hazards like greenhouse gases or ozone depleters. Or, similar to what Amelia Nestler talked about in the previous session, you may be situated on a critical surface water body and need to avoid chemicals that represent aquatic toxicity hazards. As always, it is wise to clearly document your reasons for excluding potential alternatives, as this decision may be challenged by corporate decision makers, suppliers, or other stakeholders. Some key concepts that I hope you can take away from this session include the importance of fully understanding the function provided by the chemical you're looking to substitute. Accessing the expertise of your organization's employees is essential. Don't forget that the range of options available to you is not limited only to chemical substitutions, though this is what the majority of this training focuses on. There are numerous resources that you should be using as you look to identify a full suite of possible alternatives to your use of a chemical of concern. And there are many methods you can employ to screen out potential alternatives that may be problematic in the future. Your goal is to focus the considerable effort associated with fully vetting potential alternatives to only those alternatives that are most likely to represent viable options that your company will be comfortable committing to for the long term. This is not a simple or inexpensive exercise, and you do not want to find yourself recommending an alternative that will need to be replaced in 5 or 10 years because of concerns that you might have been able to predict now.